Hello everyone, my name is Anna Farzindar. I will go over the introduction for machine learning, especially in the part one, which is this current lecture. I will go over some tasks for the data analysis, such as the classification, and then we will see how this classification could be used for the different purpose. Let me share my screen with you. First, I will go over the task of the data analysis. What does it mean? Then we will talk about the classification task, how we can build a classifier. And then after that, it's very important to see when we built our machine learning, we train our model, we prepared our classification. Now, how we can evaluate it, how the model is good to do this classification. Let me start with the definition of the classification. What does it mean, the classification? First of all, the task, what we want to do is we have a many example of the instance, like many books that we have. And then in these books, in the library, they have all of them, they are under specific category. That could be the computer science books, that could be the science fiction, that could be the children's section, etc. Then we have the specific tags, and then each book is assigned with a tag or a class. Now we have lots of the example like that. We have a mathematical model. We learn from the example, and then once a new book come to our library, now we can give it to our model as a classifier, and it will assign a class for this new upcoming book. That is the task in the machine learning that in the first lecture I will go over it. In the upcoming lectures, I will go over the different tasks for the machine learning, like clustering, the pattern detection, or the simulation of the data. Once again, when we are doing the machine learning, it's very important to understand the data that we will work on it. And by understanding the data, if the data that we are working on it are the type of the social media, or they are the type of the different discrete aspect that we have, or the type of data that we have is like the networks. Then by understanding the type of data that we have, we can have a better idea of which machine learning task we can apply on it. After that, we look at the required output based on the task, and then based on the type of data that we have. Now we can design what will be the kind of the output that we expect from the machine. Each type of a task it could be used a different algorithm. Then we can, for each task of the classification, clustering, or the other machine learning task related to the data analysis, we can have the different algorithm. Then we will decide which one that would be better for us. Okay, let's go for the classification task. For the classification task, imagine we want to classify the mushrooms. That means we have two classes, like these mushrooms are edible or they are poisonous. And we have the two classes of the edible and not edible, or the different class that we can define it. For doing this classification, we need to learn from the lots of examples. For example, we have a book. It's the guide for the different kind of the mushrooms. And each mushroom, we have some kind of the tags. like these are edible, or these group of the mushrooms, or these individuals are poisonous. Or we can have the another class like the unknown edibility. Then we have lots of the example to learn from them. And now a new kind of the mushroom comes, we will give it to our classifier, we give it to machine, and then the machine, based on what it learned from the past, it can tell you what is the tag for this new kind of the mushroom. Or another example of the classification, we want to classify the iris plants. The iris plants, we have 3 classes for the iris flowers. We call it iris setosa, iris versicolor, or iris virginica. Based on the 3 classes that we have, for each class we saw lots of the example from each class. And now when a new iris, kind of the iris flower comes, now based on the different aspect that we learn in the machine learning in the past, now machine can tell which class it will go to, what will be the label for it. Now, what is a classification task? When we are doing in a machine learning, how we can say we are doing the classification. First of all, as I said, what is given to the machine is the set of classes. These are the tags that we have for the class. We have for the iris, we have 3 classes of the iris. After that, what is given? It's a lot of the example of each class. Now, by giving that to the machine, what machine that will do, using some algorithm and some mathematical model, that will we will prepare a classification model. And then when a new instance comes, now the classifier can say what will be the class assigned to this new instance. In this diagram, we have the different level of education from the children, 11th grade, going to the college, different degrees to the doctoral degrees. And then in the other part, we have the age of the people. We have the target. These are the people that we want to put them in interested class. Imagine we have a marketing campaign for the people that they are students, or they are in the specific education, they continue the specific education. And then we have the red one, which is the non-target people. What we want to do from the different instance or different example, we want to apply our mathematical model, and we will build our model. The blue line that you will see here, that is our model that will separate the examples in the one class as a target and other class as a non-target. As you can see here, we have some non-target in the class of the target, the red circle, in the green part, or we could have some green, which is the target, in the class of the non-target. When we build a classifier, maybe sometimes it's the precision is not 100%, but we come up to some acceptance of the rate of the error. So I will talk about the accuracy and how we can evaluate the classifier later. Well, until now, for the classification task, we know what is given to us, the tag for the class, the instance that which assigned to the class. We can learn from them. What is our goal? We want to generate a model with the ability of applying the classification task. Now we have how we can learn from the instance. That is we can have a set of the features from the example. These features, we can have we can look at that as the attribute also, and each attribute could have some value. After that, we can have the class that the instance belong to it. It's called label. And we are working with the label data. We have the different example with the label of the class. We know each example is belong to which class. Now, as an input, we will give the labeled instance with the features or the attribute and value, and we will build our model. Now, what is the features? Look at this example. For example, the first line, we can look at the different aspect in mushrooms. How we can define the features for the mushroom. We can look at the cap shape. Is it the shape is the conical? Is the bell shape? Is it flat? That is one feature. The other feature that could be the cap surface. Is it the surface, the texture? Is it smooth? Is it not smooth? What is the color? Is it brown? Is it gray? Is it purple, white? What is the odor of the mushroom, or what is the habitat of the mushroom? Based on the different features that we defined, now we can describe our instance. For example, this mushroom, it could be described by P, X, S, N, T, P, F, etc. What does it mean? P is for its class, the label for its class is the poisonous. X is for the cap shape, it was the convex, the cap surface S, other, etc. Then based on the features that we have, we can go ahead and label our instance. Same thing with the example of the iris flower. We can look at the different attribute and the value. Here, the attribute that we have, it could be for attribute for the sepal length, sepal width, petal, and the petal width. Then based on the different attribute and the measure that we can do for the petal and for the sepal, we define our attribute and the value. And we can give a value as a centimeter or by inch for the measuring this attribute. And also we have a label for the which class this iris flower is belong to. Now we describe our attribute. We assign our attribute a value. The value that could be continuous value as the, for example, the centimeter or the inches. Now we know how to describe one instance with the features. Now we can go ahead and describe many instances using the same type of the features. And that's become our example that we can learn from that, the machine can learn from that, and we can build our classifier. The classification task, concretely, what does it mean? We have our instance. What is our instance? These are the example with the features or with the attributes and value. We will give them as an input to our modeler. Our modeler is an algorithm or mathematic formula. We train our modeler, and as an output, it comes, we get one model. The modeler could be an algorithm like the simple one is a decision tree. What is a decision tree? That is we have some nodes and we have some branches and leaves. What is the node? It is the attribute-based decision. I said, okay, for the iris flower, we can look at the length of the sepal. If it's the less than the 5.45 centimeter, we go to the left. If not, we go to the right. that the node that will give us the possibility of the decision to the two decision, yes or no. The branches, that these are the different ways, the different paths that we have as an alternative value of the attribute. Which direction should we continue in the decision tree? And then when we finish our branches and comes to the leaves, what are the leaves? Each leaf has a label, which is our class. And then that means our classification is done, and now we have the new instance, and we decide what will be the final label for it. Using a decision tree, now from the lots of the example that we see, we can build, we can train our modeler. Modeler here is the decision tree as the algorithm, decision tree algorithm that will learn from the examples, and we build our model. Now a new instance come, a new iris flower come to our system, to our classifier. Now we can give it to the decision tree model, and now it's decide what would be the leaf for this new instance based on the attribute and the value that we have. The high-level algorithm to learn the decision tree, it's simply we start from the root node, that is the starting point for the yes or no. We look at the attribute and we look at the value for it. After that, we will continue the decision and the branches until we go to the leaves, and then the class tags are assigned to this new attribute. Here, in this diagram, what is given to the machine is the instance, the lots of the example. To learn from that, my modeler, which is a mathematical algorithm like decision tree, we will do the training to build the model here. The model is the output of the modeler. What is the difference between the modeler and model? It's in the modeler, in the mathematical formula, there is a training phase. We train it to build our classifier, but the model, it's the ready to use. For example, if I'm doing the data science, or you are the data scientist, you build your classifier using the instance and the modeler, and the output that will be one model as the classifier, and the user, they can just run the model, and the output that will be the new class. Then here we build our model in the green part, and when a new instance come, now we can run the model on this new instance to apply the classifier, and the output that will be a tag for the class for this new instance. In the same way, one instance to the classifier, we assign it to a class, or we can receive lots of the instance and assign them to the predefined classes. What is the training and test sets? The training is the instance that we have with the features, with the attributes and value, and they are assigned to each class. We have the label for that. We can learn, the model can learn from that. We can train our machine and build our classifier. And some part of our data which are labeled, we know their class, we can hide this class from the machine and then run this model over it. Now we can evaluate how many, what is the accuracy of the system. We know the label of this test set, but we hide it from machine. We want to see the prediction of the machine for the class, how far is from the real time. And that is the training set and the test set. Another important notion is the contamination. We should be very careful when we do the training of a classifier. When we do the training data sets and the test sets, they have overlap, we call it contamination. Because all of the work that we do to build our model and apply the classifier on it and evaluate the system, etc., everything, it's meaningless because of the contamination that we have. Then we should be very careful in the training phase. More about the classification task. The classes must be disjoint. Then there is no overlap between the classes. We have the classification task. If we have only two classes, we call it binary, like the positive or negative. We want to classify the people when they are test positive, or the prediction is that they could have a test negative. Then just only two classes, and this is a binary task. When we build our classification, sometimes our classifier, they have some mistake. It's rarely a classifier is perfect with 100% accuracy. We have some mistake. Then we will see in the evaluation section how we can detect this mistake. And then our goal is to reduce this error to the minimum, to the rate that we can accept it. Next section, I will talk about the building a classifier. So far, we had our examples. We learned from the examples. We give this input with the label training data set to our modeler to build our model. What is a modeler? Modeler is a mathematical or algorithmic approach that we will use it. It will learn from the input and they can do the prediction. The output of this phase is our model. Once again, the difference between the modeler and model. Modeler is the mathematical model. It receives the input. We can train on it and build our model. The model is the output of this phase. And the user is different. The data scientist can use the modeler to build the model, and the final user, they will just run the model to do the classification task. Like the doctor, they will just run the model built by the data scientist. Now, for modeler, for these mathematical algorithms, we can have lots of choices. It could be the logistic regression, that could be the naive Bayes classifier, some classic, the SVM, decision tree, random forest, or that could be the more sophisticated methods like the genetic algorithm or neural networks. Most of the neural networks, they are using for the classification task. One of the important aspects in the classification is the explanation. That means we get some prediction out of the machine, but how we can explain how machine comes to this decision. For example, when we are doing the decision tree, it's more transparent. We can see at which point we had the decision point, and then we go to left or right, and we can trace based on what we get this class. Imagine the task is the should we approve a loan to someone or not? And now the financial institution and the bank, they use machine learning in a large scale. Then the machine that will look at the credit history, the number of the children this person have it, what is the income, do they own a house, do they own a car, etc. They look at all its features or the attribute and the values, and then they do the decision for the giving approval loan or not. Then for decision tree or logistic regression, it's more transparent. But when we go to the neural network or the deep learning, it is really a black box. And it's very, very hard to explain what's happened in this black box to predict this class for our instance. Here, we can see the different, for the same type of a data, for the same binary class that we wanted, but by applying the different algorithm as the modeler, we get the different model for the classification task. For example, the first one is a decision tree, and then the regression, logistic regression, we have the SVM, neural network, random forest. It's quasi the same classifier that we get using the different techniques here for the two classes. But now we have three classes. As you can see, it slightly could be different, and the model we get at the end. If we go to the four classes, the shape of our model, that this purple line are the shape of my model. Or even if we go for the more complex model by using the different techniques, neural network or the random forest, or model that will be different. Then we need to evaluate the different model to see which one is better for our application or for task. And here it's the even more complication that we have with the different systems. Now, as you can see, we have lots of the choice for the modeler, and now we want to see which one is better. Usually it doesn't make sense. You said, okay, I tried random forest, and that's what I choose for my classification. Usually we try the different modelers, we try the different algorithm, with the different parameters, and after that we can say, okay, now we look at the evaluation of the system, we look at the accuracy, and we will see for the using these modelers, this mathematical algorithm, considering this type of the data based on the evaluation, now I choose this modeler for that reason. Sometimes it's hard to say, okay, just one modeler I will use. We want to combine several modeler. For example, here in the ensembles, I have the input instance. I have the input instance to train our modeler. I have three modeler A, B, and C. We train them. Output of each modeler, that will be one model A, B, and C. And now in the ensemble, we have a combination function. The combination function that will say, okay, now I can look at the tag that they will give me for a new instance, and I will, using this combination function, I will come up with a final model that will decide what will be the tag for this instance. Basically, the combination function, it could be very simple, like just the average of the votes outcome of the algorithm, or we can have some weighted voting, said the vote of the model A is more important for me than model B and C. I'll give it some score to boost this score. Or you can have the complex combination function based on the importance of the features or the importance of the one dimension over other, and then how we can combine the output of the models. Here, It's this in this image. We have the model 1, model 2, and the model 3 as the output of my modeler. I have a combination function here in the middle, and then as the output of the ensemble, it's based on the decision of the combination of the different models. We started from the simple one as the modeler, which was a decision tree, but we can go and make it more complex. By now, recently, the neural network is very, very popular, especially the deep learning. How does it work? Neural network and deep learning start to become popular from the computer vision. As the input, we have some layer for that receiving the input, some neuron. These neurons that will pass the information to the next layer. For example, here we have the pixels. The output of this layer that will be input for the next layer. That here, that will be the edges that will be detected. Then the next layer, the neurons that will work on it, and then they put the edges together. Then it comes the combination of edges that makes the object part. And after that, the next layer, that will be the object models that will be detected, like the faces of people. As you look at here, we call it deep learning because when the neural network started, we had just a shallow one layer, for example, between the neurons. But now, in the more advanced deep learning, we have many layers between the input layers and the output layer. And what we have, we have the loss function. Loss function, it means we want to reduce the amount of the information that's lost in our between the neurons and in between each layers. We will pass the information, and also we can have the back propagation. Sometimes the information they go backward and then correct some function and then come back. This back and forth that will give us the good classifier. For example, here is an example of the note that based on the different layers and the neurons that we have the detection of the face. And that was a funny example because that was the lots of the learning over the different faces as an example that we had. And then as the output here, this neuron can detect the cat face. We never give this learning information to the machine, but it's understand the cat node. And that was one of the surprise of the early deep learning when it was deployed. And nobody can explain it because especially when we do this, deep learning is very black box and we don't know what's happening. We can just control some part of the structure and the function, but we don't know really what's happening in this black. The next topic that will be I will talk about the evaluation of the classifier. For now, what we learn in the first part of our lecture is what is the classification task, what is the labeled data, the example with the feature, different features with the attribute and the value and with the class assigned to each of them. We can learn from it. We can choose our modeler. Modeler is a mathematical formula. We will apply the modeler over the input data and the output that will be a model. And then we have the training set and the test set. The test set, we hide the label, and then we'll see how the prediction of the machine is close to what we know it. That is the part of the evaluation. that I will elaborate in the next upcoming then I will continue in the part 2 on the evaluation, and then especially I explain. Usually we don't train one modeler, right, like decision tree or deep learning, and then we'll see that was my best classification. We go over the several modeler, we train several modeler, we evaluate them, and then say based on the data, based on the task, what will be the best classification for us. Thank you for your attention.